At some point, if you have damage, you're going to have a new Canard stabilizer to install. And they're relatively straightforward, but you have to just kind of understand the principles here. Now, if you've got a new stabilizer, it'll come without the holes drilled that hook up to the existing holes in the Canard spar. So what we'll do is we'll take that new stabilizer, we'll push it as far onto the spar cap as we can. Fore and aft, we'll center it because there'll be a little bit of movement fore and aft, so we'll center it up that way. We'll shove it back far enough to where it's about 3.1 inches, 3.23 inches from the leading edge of the spar cap to the leading edge of the stabilizer. And the big thing here is you want to check the other side because it's not so important as to where the measurement is. You want the same distance on both sides from the leading edge of the spar cap to the leading edge of the stabilizer. So that you pair up with the other side. So now we've got the unit located fore and aft. We push back, we measure that distance there, and then to line it up vertically like this, all you have to do is get in front of it, and the leading edge of the Canard stabilizer should be roughly the same as the leading edge of the horizontal stabilizer in the tail. Not rocket science. So we just line it up with the leading edge of the horizontal stabilizer. We've got it back about 3.1, 3.2 inches from there to there, which gives us the measurement of the other side, assuming it's the same. And at this point, what will happen is I'll knock the front two bolt holes in. And we can do that using the holes in the spar as a guide. So I'll put the front two bolt holes in, but that's all. Once I get the bolts on, I'll snug them up a little bit. Don't make them real tight, snug them up. And then I'll put the cowl together. Assemble the top and bottom halves together. Push this back to make sure it's seated and everything's tight. And then I'll measure the distance from the trailing edge of the elevator to the lower cowl. And by only having the front two bolts in here, it gives you an advantage to move the stabilizer a little bit. So consequently, I'll measure that distance, measure the distance on the other side, and put the same distance in here as the existing side has on the other end. So basically what you end up with is an equal gap on both sides. This is parallel with the stabilizer in the back. You've got the proper distance to the leading edge. These two are in. And usually what I'll do is when all this gets assembled for the front two bolts, I'll just latch onto it with a pair of needle nose vice grips with some tape to hold it in position. Needle nose vice grips tape back here. Put the cowl on, and then once this is located this way, because this distance is the same as the other side, then I can go ahead and use the hole here in the spar cap, knock these rear two holes in, and at that point, you've got a stabilizer installed, should be ready to go. Now, if we replace the Canard spar, that's a little bit bigger issue. And the Canard spar, the important principle to remember here is the caps on the Canard spar. If you've got say you're getting a new spar, but you've got the old surfaces. Okay, the spar caps obviously determine when it's installed the angle of this Canard cord-wise to the engine. A guy has to remember the biggest thing here is that the spar caps, which we measure with a digital protractor, that angle has to be below, a little bit below the thrust line of the engine. Now, what I'll always do is I'll get a digital protractor, put it in the area behind the rear window to the fin, zero it, come up front, and then I'll put the same digital protractor aiming the same direction. I don't swap it around. Aiming the same direction, I'll put that protractor on top of the oil cooler to see what the thrust line of the engine is relative to the airframe. The thrust line of the engine is supposed to be 3.5 degrees, 3.5 degrees. But like all things, it seldom is that. Sometimes it's 3, sometimes it's 4, it varies a bunch. So what we have to determine is what we need to do to keep it below the thrust line. And of those two figures, say we measure this engine, and this engine is only 3 degrees, not 3.5 down. Well, the 3.5 is a minimum. So if it's 3, I still figure 3.5. If this thrust line is 4 degrees, a half a degree below what it should be, that's okay too, but now I take the 4-degree reading in reference to the spar caps. I take it so that it's the lowest of the readings. It's the most down thrust of the two. So that's the first variable. You got to figure out the thrust line and which one of those two figures you want to work with, either the thrust line or what the thrust line actually is. Next thing that complicates it a little bit is the spar caps are welded up in a fixture, and they're really, really close, but there's a very, very slight difference in the spar caps. And just with all the welding that's done, you just have just a minor variation. And normally what we're talking about on the spar caps is a variation of maybe only 2 or 3/10 of 1 degree. I mean, it's like a hair. But nonetheless, we have to take that into account. So what we want to do is when we install this spar, I'll go ahead and put the spar up here. Of course, all this will be off. I'll put the spar up here. I'll get a pair of vice grips with some tape on them so it doesn't mar anything. I'll put the vice grips on, locate. It's kind of easy to locate the way the spar goes in the side frame. There's really only one way it'll do it. And I usually locate the spar flange on the inside of the side frame because I use the side frame holes as a guide to drill through the spar. And I'll attach the spar with the vice grips. And then I'll get the digital protractor and I'll put it on the spar cap. And I'll see what the angle is. And with a 2 or 3 tenths of a degree variation, I'm always looking at the spar cap that's the flattest, because the other one's going to be lower. And you can be lower from the thrust line and not have any problems at all. You can be 2 degrees lower than the thrust line and not have any problem. But you cannot be the thrust line or higher, or it sets up an oscillation. So I'd rather be lower than higher. And what I'm normally figuring is if I take the spar cap that's a little bit flatter than the other, and I base off it, I know that the other spar cap is lower yet, which is okay, which is better. That's what I want. So when I'm doing this, I'll take the spar cap that's kind of the flattest, and put a digital protractor on it, and I'll bring it down to where it's either the 3.5 degree thrust line, if the thrust line is actually higher. If it's the 3.5 degree thrust line I'm looking for, I'll go a 1/2 degree lower than that. Or if the engine happens to be sitting lower at 4 degrees, then I base that 1/2 degree I want more off that 4 degree actual thrust line that's there. In other words, if I'm going to air, it's going to be a little lower, not a little higher. So once I get the thrust line figured out here, I'll put the digital protractor here, I'll work the spar around here until I'm getting, say this is, I think this engine, the thrust line is actually 4 degrees, not the 3.5 that it should be. So based on this 4, I want the surface that's the flattest at about another 1/2 degree lower. So I'm going to want the surface that's the lowest, probably about 4.5 degrees. And then this one, if it's 2 or 3/10 off, is even a little bit lower yet, which is what we want. If I adjusted it to this one at 5/10, and this one was flatter, it'd be up closer to the thrust line, which we don't want. So you've got some variables here in the thrust line and these end caps, and you have to kind of understand what you're trying to achieve, which is the Canard spar caps being a 1/2 degree lower than the actual thrust line of the engine, or the 3.5 degrees. And then once you get that kind of figured out and this right, the big thing here too is the Canard spar should be, if you look at it straight back, should be reasonably parallel with the engine mount cross tube that it's in front of. That levels it out this way. From the bottom, it should be roughly parallel to that same engine mount cross tube on the bottom. So that's kind of how you square that up. We know that this is how you do the Canard with the tail. That's squared up. So now you put this new spar on. If you've got an existing surface stabilizer, you can just put the stabilizer on, knock it back to that same measurement we had before, 3.1, 3.2 inches to the leading edge. Or if it's just one, match it up with the other. And then at that point, you can use the holes in the old stabilizer as a guide to drill the spar cap holes. Same thing, you know, you want to drill a front 2, leave the back 2 open, put the cowl on, align the rear end gap where it needs to be, lock this in place, take the cowl off, and drill the rear holes through the spar cap. Now, the rear holes in the spar cap, if you have, say, a new surface with no holes anywhere, what I try to do is I come back, I come in from each end of the spar cap about 1/2 inch for the attach bolt. So it's about 1/2 inch back from the leading edge on the front one. It's about 1/2 inch forward of the trailing edge of the rear one. So I want the bolts in about 1/2 inch from each edge. And then I want them as close to the spar cap as I can get it, because that's where a little more structural integrity is. However, you can only put the bolt so close to the spar cap because you've got to put a nut on it. So you don't want to make the mistake of making this bolt so close to the spar cap you cannot get a nut on. And normally what I'll do is I'll want the bolt from about 3 to 4/10 of an inch inside the end of the spar for the location that I drill. And a guy's got to be real careful here, because if you drill it and you mess it up, you pretty well messed up a spar. So that kind of gives you a little bit of an idea how to put the surface on, how to put the spar on, with the variables involved with the thrust line, the actual thrust line of the engine, and the small variation in the spar caps, to make sure that you're at least 1/2 degree below where you need to be. And in that case, and like I say, I've seen Canards installed in the field where the spar caps were 2 degrees below the thrust line and they were fine. Okay, one more thing that we need to address here is when the spar is installed on this side frame, before the stabilizer goes on, you've just got the new spar here, spar cap hanging out, no stabilizer on it. We also need to figure out how to position it side to side so it's kind of even. Well, the way I do that is I'll take a straight edge, and I mean it's got to be very rigid. This is a channel structure here, a straight edge that's 4 feet or a little bit longer in length. And what I'll do is I'll take this straight edge, I'll run it down the fuselage contour underneath the static port. So I get the fuselage contour here, and the straight edge goes forward underneath the spar cap. And the big thing here is I get the spar caps positioned evenly with the straight edge from both sides. Normally, and here again we won't have the surface on here, normally the trailing edge of the spar cap comes out pretty much even with the outside edge of this straight edge that I have here, this particular straight edge. But you just want to use this long straight edge to even up the spar side to side on both sides, and when that's done, then you can lock down the spar clamps that hold the spar to the forward engine mount cross tube. So this is the way I locate it side to side. Okay, now this is how it looks from the bottom. Once again, I've got the straight edge alongside the fuselage after the firewall. It extends forward, and normally what will happen with this straight edge, and it'll vary with the thickness of the straight edge you've got, but as it comes forward on this channel, usually the outside edge of this channel piece, the straight edge, will be touching pretty much the outside edge of the rear of that spar cap. But no matter where it touches, the big thing is you just need to have it even with this straight edge on both sides. So I hope that helps you with the installation of the stabilizer and the spar. And if you have any questions, give me a call.